Let's look at this question. So the question is saying that this is an exam question. It came in 2017. Yes. So the question is saying that arrange the following compounds in order of increasing lattice energy, where we have sodium chloride, magnesium chloride, and magnesium oxide. So they want you to arrange, starting from the one that is the smallest to the one that is the largest. So how would you go about this one? First, let's try to make a very quick throwback to lattice energy. If you've watched my video, if you've subscribed to our platform, I have already taught the whole topic about lattice energy. I've explained in depth, I think, in details. So this time I'm just solving an exam question to just apply what we've learned. But in this video, I'm going to teach something that I never taught. Okay, that's why I'm recording this one, because I forgot to teach just a very single concept. Yes, of how to answer these kind of questions. There is this concept that you need to be aware of under lattice energy. So even if you've watched my lessons, for those who have subscribed, make sure that you watch this video. Okay, yeah, there is this important concept that I'm going to show you. Okay, so first let's define lattice energy. So lattice energy is the change of energy that occurs when a gaseous ion, when gaseous ions react to form a solid compound or a solid ionic compound. So here's an example. Let's say you have sodium, which is positive, right? It is a cation, reacts with chlorine. What is going to be formed? So this is gaseous. This is gaseous. We are going to have sodium chloride, and it's going to be solid. This is an example of a reaction representing a case where lattice energy is released. Okay. So lattice energy is calculated using this, or represented using this formula: constant times Q1. Q is representing the charge, which is this one here, okay, times Q2, which is the charge for the other let me just say other element involved in a compound, okay, over R. R is like a distance between the two compounds, which they rarely give you. So one thing that you need to know is that lattice energy is inversely proportional to radius. So if the distance between them is large, it means that lattice energy will be low. Okay, but if it is opposite, the opposite will happen. You know how inversely related quantities interacts, right? Now my focus here will be on what is on the numerator here. We are having the charges. So when you multiply the charges, if you get a large number, it means that this compound is having, or this whole reaction is having, a very high lattice energy. Okay, mean that the lattice energy is high. If when you multiply you get a very small number, it means that even the lattice energy will be what? Will be a very small lattice energy. So they are directly proportional. So I will be using the portion which is the numerator to help me answer that question. Okay, I'll only take the numerator portion, and this constant I can just ignore it for now. Okay, because the constant is not given in that case. So I want to focus on this portion. Okay, so what I'll be doing is that I'll be getting a compound which will be an ionic compound, and then I'll be getting the charges of the elements involved in a compound. I'll be multiplying them. What I'll be getting will be representing how large the lattice energy is going to be. Okay, yes, Q represents the charge. So I'm going to get them one by one. I've been given what? I've been given sodium chloride as the first one. I've been given Mg, which is magnesium chloride, and magnesium oxide, right? So what I'll be doing is this. This one, if I were to write the ions of the elements involved, sodium has got the charge of 1, right? Chlorine has got -1. It's more like there is -1 here and positive 1 and -1 here. Okay, how about this one? It has got what? Magnesium has got a charge of 1, but no, it is not 2. The charge of 2, but chlorine has got a charge of what? A charge of 1. So I'll just put a negative here. So these are the charges that I'll be multiplying. And then magnesium here, it is having what? Oxygen, it is having the charge of 2. So these are the charges. If I want, I can put a negative here. Let me just put it a, at least it can make sense. Yeah, just say it's like there's -1, here there's like +1. These are the charges that I'll be multiplying. So I'll get this one, I'll multiply this times this, I'll record. Multiply this times this and record. Multiply this, and the one that will give you the largest, it means that it is the one that is having the largest lattice energy. Now they want us to arrange them in which order? In order of increasing. So starting from the lowest to the largest one, right? Right. So let's do it right now. So I'll start with sodium chloride. Sodium chloride, I'm having sodium positively charged, right? And chlorine negatively charged. So here's like the charge of 1 and 1. And what is 1 times 1? We are using this formula, which is equal to charge 1 times charge 2. So I know that you are thinking that I'm going to get -1. But in this case, we just ignore the negative, okay? So we wrap by the modulus, and I'm just going to remain with +1. Have you seen? Yeah. So we focus on the magnitude, not on the sign. Only the magnitude is our interest here. So let's go to the other one. So we have MgCl2. So Mg has got the charge of what? 2, right? And then chlorine has got, it's more like a -1. Multiply 2 times -1. I know you're going to say, no, it's -2. I'll wrap them in the moduluses so that I can end up with a positive thing here. Have you seen? So this one, the lattice, I mean, these are representing the magnitude of the lattice energy, like how large it is going to be. Okay, this is not the lattice energy. This is just like helping us to know how large the magnitude of the lattice energy will be. Okay, because the lattice energy, we can't calculate it like looking at the information that we've been given. Of course, the formula is there, but we haven't been given enough information to calculate it. So you don't even have to conclude that, no, joules. Don't write joules, no. This, let me just say, it is dimensionless. It is just helping us to see the magnitude, like how large is it going to be. Don't say joules, no. You might even get it wrong, even if you're in the right path, because it's just saying that you are calculating the lattice energy. Okay, let's proceed. And we go Mg. Oh, these we have Mg2 plus oxygen. Okay, so 2 times 2 is going to be what? This one is negative, right? This is negative. When you multiply, -2 times +2 is going to be -4, right? And it's going to be +4. So this one is going to have the large magnitude, second from the largest, third from the largest, right? And they want us to arrange them in what? In the order of increasing lattice energy. So I'll start from the lowest. So this one will have the lowest lattice energy, which is going to be followed by MgCl. So they'll be increasing in this manner. So, but at least when you are solving these, at least show these informations. Yeah, show the information at least. So this is how you do it. So this is not the lattice energy. It's like the magnitude, like how large is the lattice energy. So like this is just saying that the lattice energy for this one, since it is having 2, it is twice larger the lattice energy of this one in terms of the magnitude. Like it is large. Yeah, this one is very large, right? So this one cannot compete with this one. This is how you do it. I hope that you've understood. Yeah. And this question came on the exam in 2017. So make sure that you take note of it. So take it serious. And I hope that you have understood. And in case you haven't subscribed to our video lessons where we simplify chemistry, biology, math, and physics, make sure that you subscribe. on our platform, so that you are going to find video lessons that have been recorded in advance, where we explain like this, while we dig deeper where possible, and we simplify where possible again. Okay, and yeah, you're going to find a lot of materials, videos and soft materials there. See you in the next lesson, and subscribe to our YouTube channel so that you can be getting access to videos where I'll be solving most of the challenging questions of the exam. Okay, but to have access to our full lessons, like they are organized lessons, you just have to watch them in order. Okay, they are organized according to your syllabus. Subscribe to our platforms. The number is there on the screen. Make sure that you contact me. I hope you have a very nice day. Okay guys, so this is our platform where you access our materials. So you access our video lessons. So just click on videos, then depending with the term, if it is term 2, you choose, then you choose the course. So we have math, all these topics, the videos are here. In chemistry, all these has been taught. So there are full lessons for thermochemistry, all these lessons, and there is even atomic structure, periodicity, chemical bonding, organic chemistry. All the video lessons are here. All these are the video lessons. Even documents. We have solved materials. All the materials are here. Okay. So all you have to do is subscribe, and you access all our materials. Okay. So make sure that you subscribe so that you can access our videos and our documents on our platforms.